Hello and welcome to this video. I'm Balwant Babli, Specialist Solution Architect at Amazon Web Services. Are you looking to optimize your Timestream queries, improve performance, and reduce costs? Query Insights is here to help. In this video, we will take a closer look at this powerful feature that is free to use and show how to use it to get the most out of your data. Before we dive into Query Insights, let's take a quick look at how the Timestream storage layout looks like. This will help you to understand what Query Insights is providing and how it can be used. So when you ingest data into Timestream, Timestream automatically partitions data using timestamps, that is temporal partitioning. And it also partitions using partitioning key and dimensions, that is spatial partitioning. This approach is designed to distribute write traffic and also allows for effective pruning of data for queries. To further simplify the pruning concept in Timestream, let's say this simple select query is sent to Timestream. Based on the time filter, it will prune out the partitions which are not related to this select query. So in this case, it will scan only 2 days of data. On top of it, let's say if device ID is a partitioning key, and based on the device value you sent, it will do the spatial pruning. Now the challenge was you would not be able to quantify how much temporal and spatial coverage was happening. With Query Insights, that problem is solved. You'll be able to exactly see how much temporal and spatial pruning is happening, and based on that you can optimize your queries. Now that you understood how the Timestream storage layout works, let's go ahead and do a demo on what Query Insight exactly provides and how it can be used. I'm in the Timestream console page in the Query Editor tab. For this demo, I will already loaded two tables. One is demo and the other one is demo aggregation table. Demo contains a sample infrastructure monitoring data where we are monitoring the memory and CPU of hosts in a region. Demo aggregation table is automatically populated using Timestream scheduling query, where it runs hourly aggregation from the demo table and loads into demo aggregations table. Now let's go ahead and run a simple query and enable insights. Select start from demo database and I'm going to choose demo aggregations. To enable insights, all I have to do is click the enable insights button and run the query. You could do the same using API as well. Refer to Timestream documentation how to enable insights using API. Now that we have enabled the query insights, we have a wealth of information, that is query spatial coverage, query temporal coverage, and metrics. Now let's understand how this information can be used to optimize your queries. Starting from left, we have query spatial coverage, which has the table ARN for which the spatial coverage is displayed, and the spatial coverage percentage itself, and the partition key. In my case, it is host underscore ID. And if you do not apply your partition key as a pruning as a filter, you'll see 100% as a spatial coverage. So that's what you see it here. Since we did not apply any partitioning filter, it's scanning the entire 100% spatial coverage. Now moving on to the temporal coverage, here also it shows the table ARN for which the temporal coverage is being shown, is being displayed. And it for the max query temporal range, since we did not apply the time filter, it is showing the entire temporal range for this table. And the metrics part, it shows there is one table involved in this query, and the output rows and the output bytes. Now let's go ahead and check out the performance metrics as well. So this query took 8.5 seconds to run, and it scanned 1.62 MB of data. Now let's see how we can optimize the query. Let's add a filter for spatial pruning and see how it changes the performance metrics and query insights. For that, let's say if I want to run only the output for specific host, I'm going to add that as a filter, host underscore ID host 1. So this is my partition key. So I'm going to run this query. Yep. Now you see the spatial coverage area is reduced to 0.01%. Let's go ahead and check the performance metrics. Before it was taking 8.5 seconds, but now it almost after like reduced to half. It took only 4.685 seconds, and the bytes can also reduce to 8 to 8 kilobytes. That is half of the bytes can from before query. Now let's say if we want to run a time filter also, I want to check the data for host one like last 2 hours only. Let's see how that improves the query. Time between got 2 hours and now. Let's rerun this query. Oops. Okay. It further brought down the duration to just 700 milliseconds, and the bytes can reduced almost 40 times from the original query. Let's go and check the query insights. As you see, before it was showing the complete temporal range. Now it reduced to 2 hours. That is what matches with our requirement. Overall, adding both time and partitioning filters helped the query response time reduce 10 times and bytes can reduce to 40 times. So, or it effectively utilizes the compute resources, which can reduce cost, increase query throughput, and improve resource utilization. Now that we understood how the query insights work for single table, let's go ahead and check how the query insights work for multiple tables. Here I already pasted a query which is querying demo aggregation table for like last 23 hours and the raw table for like last 1 hour, and I'm doing a union all in the end. I put this complete query in the CT. Let's go ahead and run the insights for this one as well. So here we have the spatial coverage details. It shows the most suboptimal table. In this case it's showing us demo aggregation and the coverage is 100%. And same with temporal coverage, it shows the suboptimal table and it's again showing demo aggregation, and the max temporal range is 28 hours. In my case, I would not consider suboptimal because that's what I am querying from the demo aggregation table, so it matches my requirement. But let's say there is a use case that you're running scanning only last 1 day of data, but you see temporal range for 7 days. That's when you double check the query and to make sure you are using the right filter uh, to match your temporal range requirement. In the metrics, now it shows table count is 2 because there are 2 tables were involved in the query. Now let's check the performance metrics. It took almost 1 second and it scanned 4.20 kilobytes. Let's reduce the spatial coverage and see how much it benefits the performance, and also see the difference in the spatial coverage. I'm gonna add the and host ID equals to host 1 and rerun the query. As you see, the spatial coverage is still 100%. If you closely observe, it's now showing the table ARN as demo. So any idea why that could happen? The reason is we did not add the host ID filter for the demo table. So let's go ahead and add that and see the spatial coverage improvement. And rerun the query. As you see, the spatial coverage is now reduced to 0.01%, and the performance wise, the response time reduced 4 times and the bytes can reduced 50%. That's it for this video on query insights. We have seen by adding right filters and pruning the data by using this powerful feature, we are able to significantly improve performance and reduce cost. There is no additional cost for running query insights, so be sure to take advantage of it. If you have any questions or feedback, please do not hesitate to reach out to us on the email displayed here. Thanks for watching.